In this video, we're going to be looking at the graph of the tangent function. It's quite a bit different than the other sinusoidal functions, and it really kind of goes back to our unit circle and all of that. So I'm going to show you a unit circle here, and with the unit circle, remember that sine pertains to y, cosine pertains to x, and tangent is the ratio of y over x. So if you think about that, if you look at 0 radians, you're going to have 0 over 1, which is 0. And then 1/2 over root 3 over 2. You're going to get a decimal here. This is going to be 1 here. So this is going to be a decimal between 0 and 1. This is going to be 1. This is going to be more than 1. And then what's really interesting here at the pi over 2, 1 over 0 is going to be undefined. And then you have a negative value larger than 1, negative 1, and then a negative value that would be smaller than 0, but not by a lot. This is going to be 0. This is going to be just over 0. This is going to be positive 1. This is going to be a little bit larger, and then we have undefined again. And you're going to have that cyclical pattern as you go around. The decimals are a little tricky in here, and we'll kind of look at that. And we're just looking for the general shape of the graph. So the shape of the graph here is actually going to look like, I guess, curves going up always. So they're always increasing for the parent tangent function. So this is h of t equals the tangent of t, and you have your vertical asymptotes at those locations where the tangent is undefined. And that occurred at pi over 2, 3 pi over 2, and if you did your coterminal angles, it would be negative pi over 2, negative 3 pi over 2. So the domain is going to be everything except for your multiples of the pi over 2, the odd multiples of that. The range is all real numbers. There's no limit as to y. And the period here is pi for the parent function. And then your vertical asymptotes for the parent will be pi over 2 plus n pi, always increasing. And then we do have our transformation. So we have f of t equals a times the tangent of bx plus c plus t. And that's technically a little bit of a typo there now that I'm looking at it, because if the input is t, this should also be t. And then your period will be not 2 pi over b, but just pi over b. So that will tell you how quickly you have your curves. And then our vertical asymptotes, there's a couple ways that we can do that, and I'm going to do the inequality way, and I'll show you that in a minute. And then the rule of ND is very similar to what we've already done. So I'm going to do this graph here. If you're following along with the packet, it's on page 48. If you're just watching the video, you can just kind of do a graph on scrap paper. So sketch a graph for each function showing at least 2 periods. Label an appropriate scale that includes vertical asymptotes and where the function crosses its center line or midline. So those are synonymous. All right, so what I'd like to do here is kind of start with the 1. So my center line here would be at 1. So a equals negative 6. And if you need the refresher, we can write it up top. So y, or f of t if you prefer, equals a times the tangent of b t plus c plus d. So a was negative 6, b was 0, b was 1, c is 0, and d equals 1. So that's where I'm getting the 1 here. So your midline is going to be the equation y equals 1. And then the fact that this is negative means that it will be inverted. I am going to go up by intervals of 1 here. I wouldn't worry too much about your axes. As long as you can show a couple key points, you'll be fine. So I know this graph has got a lot of lines here, but it's not really necessary. All right, so I have 1, and I'm going to go up to 7, and I have 1, and I'm going to go down to negative 5. Okay, so here I'm adding 6, and here I'm subtracting 6. And then we'll just use that as reference in a moment. All right, and then the big thing that I'm looking at is pi over 2 is less than theta is less than 3 pi over 2. So as I'm looking at that, there are no transformations with B and C. So here, all that I need to do is draw my vertical asymptotes at pi over 2 and 3 pi over 2. And I'm asking for at least 2 periods. The other thing to remember is that the period function, the period is pi. It would be pi over b for transformations. In this case, it's just going to be over 1. And therefore, our interval, I like to talk about the intervals to get those key values, is going to be pi over 4. So right now, I'm going to just start at 0, and then I'm going to go out by pi over 4 for a while. So this is going to be pi over 4, 2 pi over 4 is going to be pi over 2, 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, 6 pi over 4 is going to be 3 pi over 2, 7 pi over 4, 8 pi over 4 is going to be 2 pi, and I'm going to continue. So I have 9 pi over 4, 10 pi over 4, which is going to be 5 pi over 2, 11 pi over 4, and then 12 pi over 4 is going to be 3 pi. I'm going to go just 2 more, and then that's 12. So then 13 pi over 4, 14 pi over 4 is going to be 7 pi over 2. And you can kind of look at your patterns. So I have the odd consecutive integers, 1, 3, 5, 7, 9, 11, 13. There's lots of patterns here. And then 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. So don't let that intimidate you. All right, we're going to put in our vertical asymptotes at pi over 2. I'm going to put another vertical asymptote at 3 pi over 2. That was not lined up very well, so I have a little bit of a curve there. Doesn't have to be perfect. All right, and then 5 pi over 2. Okay, and then 7 pi over 2. Okay, all right, and then at the halfway point between your vertical asymptotes, your graph will always cross at the midline. So I have the point here at pi. I have a point here at 2 pi, and I have a point here at 3 pi. And then this one had a negative a value. I actually would have a point here as well. And because of that, it's always decreasing. So at the quarter points, so I'm going to start here because I think it's a little bit easier to see. I would add the 6 to the 1, and my y value would be 7. Here, my y value will be negative 5 at 3/4 of the way through the period. And then the same thing over here. So I would have this point, and then you can just kind of continue that pattern. So I know I only asked for 2 periods, and I clearly added a little bit more than that. No big deal. And then you just want to try to give it a curve. So you're going to come down here. And then you would just continue drawing your kind of S-shaped graphs. These are always decreasing. And the next one we're going to do is also always decreasing because it's a harder one. And I wanted to show you one that was a little bit more complicated. You could add that all vertical asymptotes are, I guess, x, let me rewrite that, x equals pi over 2 plus pi k, because the period was pi, where k is an integer, okay? And then we have our interval. All right, so let's go over to one that's a little bit harder. So this one's going to be on page 52. So this is page 52. Same instructions where we're doing at least 2 periods, show an appropriate scale, all that good stuff. So this time we have f of theta equals negative 3 over 2 times the tangent of pi theta minus pi over 2 minus 3. So there's a lot of stuff going on with this one. So first thing I would do, and you can pause the video if you want, is you can find A, B, C, and D. A will be negative 3 over 2. B will be pi. C will be negative pi over 2. And then D will be negative 3. So if I think about my y-axis, it's always kind of easiest to start with that midline, that center line. So you have -3 for your y value. And then at your quarter points, you're going to be going up 1.5 and down 1.5. So I'd probably just go by halves just for kind of ease. And I clearly went more than that. And then down here is kind of the same thing. So -3.5, -4, -4.5, -5, -5.5. If you had said, geez, I want to stretch this out a little bit more, you certainly could, and had gone by quarters. It really doesn't matter that much. All right, and then for a period, remember, for a transformed tangent graph, the period will be pi over b. So in this case, we're going to have pi over pi. So here the period is 1, okay, which means our interval will be 1/4. All right, so I'm going to use that to kind of go across. So this time I'm going to spread it out a little bit more. Maybe I really didn't, I don't know. So this is 1/4, 1/2, 3/4, 1, 5/4. Now 6/4 is going to be 3/2. 7/4, 8/4 is 2, and then 9/4, 10/4 is 5/2. This is feeling familiar. 11/4, and then 12/4 is just 3, and I'm going to stop there. Okay, so the next thing that I want to do is I find it very helpful to write that inequality. So the pi over 2 is less than pi theta minus pi over 2 is less than 3 pi over 2. So I don't know if I just said that right. So pi over 2 is less than pi theta minus pi over 2 is less than 3 pi over 2. It's a lot of rich language here. All right, we're going to add my number. Doesn't feel like a number, but it is. Pi is just a number, so a number divided by 2. So don't let the fractions scare you. They're just representing numbers, so it looks worse than it is. So these cancel. Pi over 2 plus pi over 2 is 2 pi over 2. But 2 pi over 2 is just going to be pi. So this is going to be pi is less than pi theta is less than, now this is going to be 4 pi over 2. So it's going to be 2 pi. And you might see where this is going now. And it makes a lot of sense because our period did not have pi in it. It was just 1. So now I'm going to divide all 3 parts of my inequality by pi. And then I'm going to get 1 is less than theta is less than 2, which makes sense because my vertical asymptotes will be x equals 1 plus k. Okay, k being my integer. Okay, so now I can go ahead and put in my vertical asymptotes. So I'm going to vertical asymptote at x equals 1, at x equals 2. Geez, that was not lined up very well. All right, I'm going to let that go. And then at x equals 3, and then at 0. Problem is I was told to use pen so that way you guys could see better. That is kind of bugging me, so I'm just going to white that out a little bit just so it's not confusing. Okay. Okay. All right, this one was always decreasing again because A was negative, and at the halfway points, this would be a point at 0.5 or 1/2 -3, 1.5 -3 for y value, and then this would be 2.5 -3, and then at my quarter points, I'm going to go up 1.5 and then down 1.5, and then I just repeat the cycle. Okay, and then I give it a curve with an arrow. And then you have your tangent graphs, your tangent curves. They are always decreasing. And then remember, the period is going to be pi over b. And I find it really helpful just to set this up with the pi over 2. And then whatever you're taking the tangent of, so the bx, bt, b theta plus c would go in here is less than 3 pi over 2. And then you solve these, you can get your vertical asymptotes pretty easily from there, and then you're good to go. All right, hope this video is helpful.